Hey, it's Mr. T from Rockbridge. So we're going to talk about the difference between discrete and continuous random variables. And so first of all, if you've heard the term discrete mathematics, you know often that is the topic in pre-calculus when you're talking about sequences. And so you're thinking about lists of numbers. There's no information between numbers to consider. And so we consider that to be discrete in statistics if we can list the outcomes, that there's a finite amount of outcomes and we can list them. Continuous, on the other hand, means there's infinite outcomes. You can't list them all because it's a continuous variable. It can be any value between this number and this number. So it's impossible to list them all, but they can exist. So basic example of the two is a discrete random variable would be the numerical outcomes of a dice roll. You could list them out, 1, 2, 3, 4, 5, 6. And a continuous random variable would be how long a string is. And you could measure the string, and it could be infinite possibilities from 0 inches to however many inches the string might be. So take a second to pause this video and think about each one of these variables. Are they continuous or discrete? Okay, so for the first one, weight of a grape, that would be continuous. How many grapes in a bundle would be discrete. Number of underpants that are stained in a person's drawer would be discrete. And hopefully that's just a discrete piece of information as well. And then percent of stained area would be continuous. When we talk about probability, we can calculate the probability of discrete and continuous situations. And on the first situation we can use some of the probability skills from Unit 4 to answer it. If you're going to roll a die until you get an even number, probability you got it on the third roll, you could say, well, I'm rolling until, so that's until the first success. That is a geometric probability model, and I can calculate it and use that model. For continuous probability, we're now saying a variable that is not a finite set of outcomes. So we don't know how long it's going to take to roll an even number. It could take days, it could take weeks. Most likely it's only going to take a few seconds. To answer this question, we need to know more information. If we're going to say that we want to find the probability that even shows up at 3 seconds, we would actually need to know the shape of this continuous probability model. And the only shape that we've already used is the normal model. So that's going to be our focus today, is how can we see the normal model applying for continuous random variables. Go ahead and check out the next handout and video that goes along.